Hello all, welcome to Ajit Video Blogs. This is Ajit Beasing, your instructor for process control. In today's video, let us see about proportional control. To start with, proportional control or P control is called by different names like correspondence control, gain control, and modulating control. Proportional control provides the controller output which is in direct relation or corresponding to the error signal. The controller output is a multiplication function of proportional gain and error. Proportional control is governed by two important parameters which are proportional gain and proportional band. The equation of proportional controller is given by the product of the proportional gain and error. Let us start with proportional gain. Proportional gain, which is also known as proportional sensitivity or proportional constant. It is just a multiplication factor of error signal. Increasing proportional gain will speed up the system's response. Coming to proportional band, it is the range of error which is to be covered between 0 to 100% of the controller output. It is given by the equation PB is equal to 100 divided by KP. Proportional controller is classified into two types based on its transmission medium. One is electronic proportional control and the other is pneumatic proportional control. Electronic proportional controller utilizes electric power to actuate the final control element. It is basically constructed using an operational amplifier and is mostly utilized for local control or a single element control like flow, level or pressure, etc. The electronic proportional controller circuit using operational amplifier is shown below. This entire circuit consists of two segments. One is the proportional controller and the other is the sign changer as shown here. Taking the first loop of the electronic proportional controller, we can find out the error signal E of t using Ohm's law. This will give us the current I1 which is flowing through this loop. The output of electronic proportional controller U of t can be obtained using the second loop in the circuit. Substituting the value of I1 in the above equation, we get U of t equal to minus R2 by R1 into E of t. Solving out the loops in the sign changer circuit, we get U of t is equal to current I2 into R. From the above equation, we can obtain the value of I2 as shown below. Solving the loop 2 in sign changer circuit, we get the value of V of t as shown below. Substituting the value of current I2 in the equation of V of t, we get the equation V of t is equal to minus U of t. Now on substituting the value of U of t which has been obtained from the proportional controller circuit, we get the equation as V of t is equal to R2 by R1 into E of t. Now on bringing the variable E of t to the denominator of the equation V of t, we get the transfer function as R2 by R1 which is equal to the proportionality constant Kp. Coming to pneumatic proportional control, pneumatic proportional controller uses air or pneumatic signal to actuate the final control element. It is composed of bellows and diaphragms which is attached to the flapper nozzle system and is mostly used for single element control. The constructional circuit of pneumatic proportional controller is shown below. It is provided with a supply pressure of 20 psi which is passing through an orifice and then reaches a reverse acting relay. From this reverse acting relay, the pressure reaches the proportional bellow by which the flapper is moved to and fro. This to and fro motion of the flapper closes the mouth of the nozzle, which in turn provides an output pressure in the range of 3 to 15 psi. There is also a spring which is being connected to the other side of the flapper, which provides a fine-tuned movement of the flapper over the nozzle's mouth. Coming to the advantages of proportional control, it helps in reducing the steady-state error which is occurring in the system and thereby makes it more stable with disturbance rejection. Increasing the proportional gain can speed up the system's response and thereby increases the rise time. It is also cheaper and easy to implement. Looking into the disadvantages, the main disadvantage of proportional controller is the presence of offset. The error in the system can never be made to zero and it responds only to the change in error. Looking into the offset, it is the residual error or a constant difference between the set point and the process variable whenever there is a load change. It can be eliminated by increasing the proportional gain of the proportional controller. This increase will lead to a pertaining oscillation in the process output. The proportional control finds its application in various processes like surge tank level process, thermal process, flow process, inner loop cascade process, etc. Thank you for watching. See you back in another video on process control.